So, car A and car B, different people surveyed. Some people said smooth, some people said rough, some people said not sure, and some people said smooth or rough to both things at the same time, whereas some only said it for one or the other. So we basically have to treat each of these like a separate kind of system of equations. Across the board, these will equal 100 people surveyed, but each of them is its own kind of survey question, and they're kind of separate. So one way to think about this is that the number who said that both cars were smooth plus the number that said A or B is smooth will equal the total of those who said A and B are smooth. So this will equal the 45 plus 20, or 65. So all the people who said one or the other, and then we have to add the numbers that said both once to the total. We don't want to add it twice, even though they show up in both the 45 and the 20, because they're actually already going to be counted twice. So if we can solve for the one or the other, or the both, we are set. So if there are 100 drivers surveyed and 50 did not respond smooth for either car, that means that 100 minus 50 did say that one or the other, so A or B, was smooth. And now we have a second number here. So if 50 said A or B was smooth, we can fill in 50 here, and that therefore must mean that 15 are the number who actually doubled up and counted in each of these two numbers here. So statement 1 is sufficient. We can get rid of statement 2 as well as the two insufficient answers. Statement 2 then tells us the number of drivers who responded rough for both cars. Now, again, since these are kind of separate systems of equations, we can solve for something similar, the number that said both were rough, or that one or the other was rough. But that won't allow us any additional insight into this column, the smooth column. So statement 1 statement 2 is going to be insufficient, and it is answer choice A on its own.